Okay, this is the review for Algebra 1B final. You can write down any 3 questions you want on a computer white sheet of paper and show it to me, and I will let you take that on the final and use it on the final. But it needs to be those 3 questions and nothing else. Okay, so the first one is a solve for y, so let's go ahead and work that out. The whole point and purpose of this is to get y by itself, so you have to get rid of all the other numbers that are on the same side of the equal sign as the y. And so whatever's being added or subtracted, you do the opposite. So I'll just do the -3 first by doing a +3. I could have also got rid of this 3x first if I wanted, because it's being added. So then you would have a 3x minus 4y equals -9. Take away a 3x from both sides. Since a -9 and -3x are not like terms, you just bring them both down. Divide both sides by a -4, and you solve for y. And the answer is that y equals, since 4 can't go into a 3, you just write it as a 3 over 4. X, negative over negative is a positive. Same thing, plus 9 over 4. Okay, I'm going to go much quicker than you're used to me going because this is review. You've seen all this stuff. It's just to refresh your memory right before you take the final, and maybe you need to watch it a few times, and that's okay. Okay, so looking at this one, there's 2 different ways you can solve this. Because it's a square, you can either write it twice, multiply it by itself because it's squared, or there's a shortcut way you can do it as well because it's a special product. Let's do it the longer way. That is the way that always works, and that's that you multiply, you distribute twice. X times x, x squared. Then the x goes to the 9. 9 times x, well, just 9x. Then do it again. 9 times x is 9x. 9 times 9 is 81. Collect like terms. Bring down what you didn't use. That's the traditional way to do it. The special product shortcut is that you square the first, you square the second, and what goes in between those is you multiply the first term times the second times 2. 8 times 9 is 9. I'm sorry, x times 9 is 9x. 9x times 2 is 18x. You get the same answer either way. Okay. Okay. Again, there's a special product on this. When you have opposite signs, you still square the first, still square the second. You just put a negative in between. It's a special product. But if you forgot that way, you can always just distribute twice. X times x is x squared. X times -7. 7 times x. 7 times 7. These cancel out because they're opposites, and you're left with an x squared minus 49. Okay, there is going to be a question like this on the final, and it's pretty easy. It's saying this x times this quantity equals 0. Well, the only way to get to a 0 is that you have to multiply something by a 0. So either this is a 0 or this is a 0. And that's what you have to write. Either this is a 0 or this is a 0. Well, if this is 0, you're done. X is 0. But if this one is a 0, you have to add a positive 11. You have to solve for x. So the answer is either that x equals 0 or x equals 11. Okay, find the GCF. There's a lot of ways you could do it. One strategy a lot of students use is they try the smallest number and see if it can go into both. But if you count by 12s, it doesn't go into 30, 12, 24, 36. So it doesn't work this time. It's a good strategy. I like to go with the factor tree because I think it's just easy to remember for students. So any way I can think of to multiply to 30, I could do, other than using a 1. I could do a 15 times 2. I'll just do a 3 and a 10 this time. I could have used a 5 and a 6, whatever. 12, I can do 6 times 2, but I'll do 3 times 4. Okay. And then can you break it down again? Well, 10 could be broken down to 2 times 5. 4 could be broken to its factors 2 times 2. Bring down the numbers that you didn't continually break down. Is there any common factor? Remember, we're looking for the greatest common factor. Well, these are the factors. We broke these numbers down to the factors, but what's common? Well, they both have a 3, and they both have a 2. So what's the greatest out of those? Well, if you multiply 3 and 2 together, you get a 6. So 3 times 2 is 6, 3 times 2 is 6. So the greatest common factor is a 6. Okay, this just says the factor, so there's lots of ways you can factor. There's the X box, there's the asterisk, there's the GCF that we just did, there's the factor by grouping. So there's the difference of two squares. There's more, but these are the ones that we use a lot in this class. So looking at this one, it's a binomial because there's two terms. How would we factor it? Well, if there's not a negative in between, the only way to factor is the greatest common factor. That should always be your first step. Is there a greatest common factor? And there's not a coefficient that can go into both, but they both have an x in common. And remember, you always want to take it out to the smallest power listed. Then you just divide. So there's no coefficient, so the 3 remains, but 9 take away 4 would be 5. Remember, that's how you divide exponents. You do it by subtracting. If I had 9, 7, 8, 9, and I divided it by 4, I would just cross out, and I'd have 5. It's the same as subtracting. 4 take away 4 is 0, and anything to the 0 power equals 1. And 1 times any number is just that number, is the identity property of multiplication. Another way to say it, though, is that 4 take away 4 is nothing, so don't even write any x. That's your answer. You just took out the GCF. Okay, so it's a trinomial here, and so it looks like it's going to be an asterisk type problem, right? Because our product problem, because there's an initial coefficient greater than 1. But it looks like there's a GCF in here, so let's see what that would be. Now I can tell just by looking at it the GCF is 5. And it looks like an x. They all have an x. So we have to divide each of these terms by the 5x. 5 goes into 36 times. x4, take away x1 would be x3. 5 goes into 15 3 times. x2 and x would be just x, subtracting. And 5 goes into 20 4 times. And we're done. Because this is no longer a square, so we can't keep going because it's no longer quadratic. So that's it. It's just the GCF. How would you handle this one? Well, you can't factor it because you have a number on this side. So you have to first get all the numbers together on the same side of the equal sign. 49 take away 49 is 0. It's a square, and there's a negative, so it's the difference of two squares, is that special product. So two sets of parentheses, it'd be a x plus 7, x minus 7 equals 0. Since it equals 0, either this is 0 or this is 0. So x plus 7 equals 0, or x minus 7 equals 0. Subtract 7 from both sides, and x equals negative 7, or add 7 to both sides. X equals 7. Okay, on this one, how would you factor it? It's not a binomial, it's not a trinomial, it's a polynomial of 4 terms, and there's not a GCF, not a greatest common factor that can go into all 4. So you factor by grouping. I'll put the first 2 together and the next 2 together. So I'm going to put a3 plus 3a squared together. And then I'm going to do a plus 3 together. What's the GCF here? It's a to the second. Always choose the smallest. You have an a plus 3. And then there's not a GCF here. When that happens, it's okay to take out a 1. So you still have an a plus 3. A plus 3 is this new GCF, greatest common factor. So a plus 3 goes together. And what's left is an a squared plus 1. The next question is a square. It's a square and there's a negative. When it's a binomial, there's a square and a square of negative. It's the difference of two squares. It's two sets of parentheses. Square root of x to the 8th is x to the 4 and 4. Some of you think of it as 4 plus 4 equals 8. Plus 9. Whoops, this should be a negative 9. Okay, looks good, but you can keep going because this is a square, this is a square, and there's a negative. So to get to 4, it would be a 2 and a 2, plus 3, minus 3. Bring down what you didn't use. So remember to see if you can keep going. Okay. So we just did 10 questions, and I want to stop. And if you need a break, go for it. But I want to show you these last two because they're worth more points on the quiz. So you definitely want to know how to do these, okay? Describe the characteristics of the graph. So of this parabola here. Well, the domain, since it's going up forever, any x value would eventually hit it. It's all real numbers. The range, though, has a limit. It's the vertex, right? So the range would be y is greater than or equal to negative 1. It's hitting negative 1, and it's everything greater than a negative 1. Forever, because the arrows point on forever. The axis of symmetry, looks like if you were to divide this in half, it's going right, splitting down the middle, it'd be that x equals 0. And the last thing is the vertex. Vertex is right, the lowest minimum point. It looks like it's x is 0, and y goes down 1. The vertex is going to have the same x value as the axis of symmetry, by the way. Okay, last one. 12th problem. I say know this because it's worth 5 points. It's worth more than the others. So if you're gonna, you might consider this to be one of the 3 that you write down. Graph the function and compare the parent function. So how do we graph this? The first step is to make a table. So we have an x, and it looks like we have a g of x. And you put the numbers in. Then we substitute these numbers in for the x. And then once you substitute these numbers in, you're just doing the order of operations. So the first number I should put instead of x is a negative 2. The order of operations, should I multiply first, should I do exponents first, or should I subtract first? Always do exponents first. Negative 2 to the second power is a positive 4. 2 times 4 is 8. 8 take away 1 is 7. If I input a negative 2, my output is a 7. If I do a negative 1, you square it. A negative 1 times a negative 1 is a positive 1. Then you times it. 1 times 2 is 2. Then you subtract. 2 take away 1 is 1. If you put a 0 in, 0 times 0 is 0. 0 times 2 is 0. 0 take away 1 is a negative 1. It's symmetric, right? So these numbers are going to be the same. Now you have to graph it. If x is negative 2, y is 7. If x is negative 1, y is 1. If x is 0, y is negative 1. If x is a 1, y is 1. And if x is 2, y is 7. Your parabola should look like this. Okay, you did a lot of work to get here, but you're still not done because it says compare to the parent function. Graph the function, we did. Compare to the parent function. The parent function, you know what? I don't usually write it down when we're doing reviews, but I'm going to anyway, just in case. So it would be x and f of x. And you're using the formula of f of x equals x squared. So whatever number you put in, you just square it, and you have the output. So I put a negative 2 in for the x, I square it. A negative 2 times a negative 2 is a positive 4. Negative 1 would be a 1, and symmetric. Okay, so let's graph it real quick. If x is negative 2, y is a positive 4. If x is a negative 1, y is a 1. If x is 0, it's 0. 1 and 1. 2, and 4. It looks like this. Okay. So, how would we describe the graph? When we compare it, there's 4 descriptions that we need to do. Okay. And I understand this takes a little bit of time to do. The 4 descriptions. 1, the axis of symmetry. Well, they're both, if you were to divide one of them in half, you divide the other in half. So they're both at x equals 0. They're the same. 2, the vertex. They're different. One is 0, -1. And then the pink one is actually 1 higher if you look. It's 1 higher, right here. So it'd be that 0 is the same, but it'd be a 0, 0. It's at the origin. Okay. Number 3, directionality. It's kind of easy. You just remember it. They both point upwards. These little arrows would go on for infinity. They're both pointing the same way. It's kind of an easy one. So number 4 is probably the most important of all these, and that's describe the vertical stretch or shrinkage. So is it going higher? I'm sorry, is the graph from the parent function, which is in pink, is it stretching, getting closer to the y-axis, or is it shrinking, getting further away? And the answer is it's a stretch. So it's a vertical stretch. By a factor of, well, let's look at the original equation. It is a 2 in front. It's a factor of 2. And then this other thing, which we just learned, is it translated at all? Is there a translation? If the pink were the first and you went down 1, you'd be translated vertically 1 unit down. And actually, you can tell by the question. See, it's the -1. That's the answer. I'm going to put a 5 here. So it's a vertical translation 1 unit down. Okay, a lot of stuff that we came over, especially that last question. Hopefully that helps prepare you for the quiz. Feel free to watch this video multiple times.